This is going to be the fourth lecture on inverse trigonometric function, which is from class 12 maths chapter 2, and in this video I'll be solving only questions on finding domain and range of inverse trigonometric functions, and I'm taking some questions. The first question is only to find the domain, and second question is we are going to find domain and also we are going to find the range of the functions. More questions I am going to solve. And to learn how to find domain and range, at first we have to learn the domain and range of principal value branch I am giving now. We must know this table at first. It is about the domain and range of principal value branch. The first column is about domain, second column is about range, and I am writing here, you see, in terms of capital X, sine inverse capital X, cos inverse capital X, and this first column, it is the domain. Domain means it is the values of X, and remember this X value must lie in the first column, which is the domain of inverse trigonometric function, and this X you may get function like this, maybe 2x plus 1, maybe 2x plus 3, like this. This x can have different functions, maybe 4x minus 5, like this. Cannot write actually equal. X may be this, x may be this, like this. So whatever value of x function, that function must lie in this domain. First column is the domain, and the whole fx, that means cos inverse, the whole cos inverse, sine inverse, tan inverse, whatever it is, the whole value must lie in the second column is the range, that is actually fx. So while solving we will get more concept will be more clear while solving. So I'm taking the first example. It is about finding domain. First we will learn how to find domain. I am taking one example, say sine inverse 4x plus 3. We are going to find the domain. Solution, you see, we have here sine inverse. Domain means we are going to only see the first column, not second column is about range. Now sine inverse x, domain is minus 1 to plus 1. So we have sine inverse of x, I'll write capital X. We have for sine inverse of x, x must be in the interval minus 1 to plus 1, close interval. That means x lies between minus 1 to plus 1, close interval, we can write equal to sine. Now in this question, in place of x, what function we have, you see, 4x plus 3. So I can write now, in place of x we have 4x plus 3 less than equal to 1, and then we have to find the values of x, possible values of x. Then to find this x, first I have to remove this 3 plus 3. To remove this 3 I have to subtract 3 in each term. So minus 1 minus 3, 4x plus 3 minus 3, 1 minus 3. In each term I have subtracted minus 3 just to remove this. I have to make x free anyhow. I am going to make x free, so at first I will remove this number 3. So to remove this 3 I have subtracted 3. So plus 3 minus 3 getting cancelled and simplifying, it is minus 4, 4x less than equal to minus 2. Then I have to remove again this 4. To make x free I have to remove this 4, and to remove this 4 I have to divide each term by 4. So minus 4 by 4 less than equal to 4x by 4, each term divided by 4, and this getting cancelled, so x is becoming free. And then this is minus 1, x minus 1 by 2. So I got the domain. Domain means values of x, the set of all possible values of x. So I can write the domain of the function is minus 1 to minus 1 by 2, equal sign, close interval. Here also equal sign, close interval. So this is how we find the domain. So this is the complete solution for the given question. Now taking next example, the second question I have taken is cos inverse 2x minus 1. So what we have here, cos inverse x domain is minus 1 to plus 1. So I'll write like this. We have for cos inverse of any function, we have the function must be in minus 1 to plus 1 close interval, that is minus 1 less than equal to x less than equal to plus 1. But in place of x we have what function? You see, in place of x you have function 2x minus 1. So I'll replace it. We have 2x minus 1 less than equal to 1. Now anyhow we have to make x free. Domain means values of this small letter x, and we have to make anyhow x free. To make x free, first I have to remove this minus 1, and to remove this minus 1 I have to add 1 in each term. So minus 1 plus 1, 2x minus 1 plus 1, 1 plus 1. I have added 1 in each term so that this 1 can be cancelled. Then I am getting like this. Then I have to again remove this 2. To remove this 2, I have to divide each term by 2. So 0 by 2, 2x by 2, 2 by 2. And then this is getting cancelled, and I got the values of possible values of x, which must be, this is 0, which must be between 0 to 1, and this is the required domain. So I can write like this: domain is equal to 0 to 1, equal sign, close interval, here also equal sign, close interval. So this is the complete solution. Very simple. We just have to know the trigonometric table and we can easily find out the domain. Now I am taking the next question. The next question is sine inverse 3x minus 5 I am taking. Now for sine inverse, very simple, we are finding domain, remember, not range in this question. For sine inverse any function, we have the function x must be in which, for sine inverse domain is minus 1 to plus 1, close interval minus 1 to plus 1. That means x lies between minus 1 to plus 1, equal sign, close interval, equal sign, remember. And in place of x, what do we have? X is given function 3x minus 5 less than equal to 1. Now anyhow we have to make x free. Inequality solving we have learned in class 11. Anyhow we have to make this x free, and to make x free at first I have to remove this minus 5, and to remove minus 5 I have to add plus 5 in each term. So minus 1 plus 5, 3x minus 5 plus 5 less than equal to 1 plus 5. I have added 5 in each term so that this is getting cancelled, and then minus 4 less than equal to 3x less than equal to 6. The second step, I must remove this 3, and to remove this 3 each term must be divided by 3. Then divide by 3 divided by 3 divided by 3. So this 3 is getting cancelled, x is becoming free, and then whatever I got is the domain. Domain means, remember, set of all possible values of x, and clearly x must be between these two numbers. So I can write like this: domain is equal to between minus 4 by 3 to 2, close interval, equal sign is there, so close interval, here also equal sign, so close interval. This is the complete solution. So simple to find the domain and range if we just know this trigonometric inverse trigo table, which is the principal value branch of inverse trigo. Taking the next question, cos inverse of 4x plus 3, and what do we have for cos inverse function? Any function, x must be where? For cos inverse domain is again minus 1 to plus 1 close interval. That means x must be between what? Minus 1 to plus 1 close interval, so equal sign. Then the function x we have here, in place of x we have 4x plus 3, and then we have to find x. And to find x, first I have to remove this 3 plus 3, for which I need to subtract 3 in each term. So minus 1 minus 3, 4x plus 3 minus 3, 1 minus 3. In each term subtracting 3, so that this 3 is getting cancelled, minus 2. Then second step, I must remove this 4, and to remove this 4 we have to divide by 4 each term. So each term is divided by 4. Then this is getting cancelled, minus 1 less than equal to x minus, you see, we got the domain. So therefore domain is equal to minus 1 by, see, close interval, because equal sign is there. So this is the complete solution. Next question is again sine inverse of under square root this, and again the same concept for sine inverse. The function that means x must be between minus 1 to plus 1. I have written here. That means x lies between minus 1 to plus 1. And in place of x, what is here? In place of x here, it is under square root x minus 1. And then we have to solve and get the value of this small letter x, which gives the domain. For that, at first we have to remove the square root, for which we need to square. So if we square each term, after squaring each term, you remember negative part will be gone. There will be negative part. No number whose square can be negative. So it will be starting with 0 now. And then squaring. When you square, remember negative part is not there. That we have learned in class 11. Solving inequalities. So remember, I am telling once again, when we square the inequation, then there will be no negative part. It will start from 0 always. So starting with 0. Then here square and root is getting cancelled, less than equal to 1. Then we have to remove this minus 1, and to remove this minus 1 we must add 1 in each term. So adding plus 1, here also adding 1, here also adding 1, and then we have got x free of any coefficient. X is free from any coefficient of x is 1. That means we got the possible set of values of x. X lies between 1 to 2. Therefore domain is equal to 1 to 2, close interval, because equal sign is there. And this is the complete solution. Taking one more question for sec inverse x. For sec inverse x, we have the domain, you see, any real number except this interval. So x belongs to any real number except minus 1 to plus 1. What does it mean? It means x belongs to where? I am explaining, you see, real number is starting from minus infinity up to plus infinity. Minus infinity to plus infinity. But we have the condition here, real number, but should not be between minus 1 to plus 1. Here 0, here minus 1, here plus 1. That means according to question, it can be any real number, but it should not be between minus 1 to plus 1. That means it can be here, it can be here. It can be less than minus 1, it can be greater than plus 1. So I'll get two parts here. One is less than minus 1, another is greater than plus 1. We are getting two parts. So I'll write like this. This implies x is less than equal to minus 1 and x is greater than equal to plus 1. When you are removing open interval, subtracting open, remaining close, remember this. Any real number except minus 1 to plus 1 is open interval. When this is open interval, remaining is close interval. So we have to write equal sign. If this is close interval, here will be no equal sign, remember. So this in equation writing, you can understand from this graph, the value of x should not be it can be in any real number except minus 1 to plus 1. That means it should not be between minus 1 to plus 1. That means it can be this side, it can be this side. Now I'll solve. In place of x, what do we have? In place of x, we have the function 2x minus 3. So 2x minus 3 less than equal to minus 1, and here same again, greater than equal to plus 1. We have to solve now. 2x minus 3. First I have to remove this minus 3. So I have to add plus 3 here on both sides. So minus 3 and plus 3 getting cancelled, getting 2x less than equal to 2. Then we have to divide by 2 again. 2x by 2, 2 by 2. So you are getting x less than equal to 1. One part you got. First part, x less than equal to 1. Same thing here again. Minus 3 must be removed. And to remove minus 3, I have to add 3 on both sides. So plus 3 plus 3. So this is getting cancelled. 2x greater than equal to 4. And then we have to remove this 2 again. Ultimately, we are going to find x. So to remove this 2, we have to divide by 2 each term. So divided by 2, x greater than equal to 2. So x less than 2, x less than 1 and x greater than 2. What does it mean, you see? I'll explain with real number. Minus infinity to plus infinity, middle 0 is there, 1 will be somewhere here and 2 is here. Greater than 2 means this side, less than 1 means left side. Less is always left side, greater is right side. So it cannot be here, it cannot be between 1 to 2. So how I'll write the interval now? We can write like this: domain is equal to this part is what? It is minus infinity to 1, infinity always open interval, and here you will write open or close, that depends on this condition. Equal sign is there, so close. If equal not there, it will be open interval. Union means together. We have another part here, 2 to infinity. So 2 to infinity always open interval. And here you will write open or close, that depends on the condition. Equal, close. If no equal, then open. So this is the solution. This is the domain for the given function. Now next, one more question I am taking for cosec inverse x. Again, for cosec inverse, the same process we are going to, almost same as for sec inverse, because domain same. So for cosec inverse x must be belonging to real number except minus 1 to plus 1. So we have already discussed this in previous question. It implies that x can be less than equal to minus 1 and x can be greater than equal to plus 1. It should not be between minus 1 to plus 1. I am explaining once again here. Minus infinity to plus infinity. Minus 1 here, plus 1 here. So it can be in any real number, but it should not be between minus 1 to plus 1. That means it cannot be here, it can be this side, it can be this side. This side means less than minus 1, so correct. This side means greater than plus 1, so oh yes, greater than plus 1. When rejecting open, remaining close. If it is open interval, here will be equal. If it is closed interval, here will be no equal sign. Since it is open, so we are writing equal. When we are rejecting open interval, remaining is closed interval, that you have to keep in mind. Then we have to solve now x function, x, what we have? This is the function now, x. So 3x plus 2 less than equal to minus 1 and 3x plus 2 greater than equal to plus 1. Now I will solve it. At first removing this 2. So minus 2 on both sides. This is getting cancelled, 3x less than equal to minus 3. Then dividing by 3, 3x by 3 minus 3 by 3. Now finally I made x free, x less than equal to minus 1. Same thing here again, I have to remove this 2, subtracting 2 on both sides. So this is getting cancelled, then 3x greater than equal to minus 1. I have to remove this 3 again, for which I have to divide by 3. And then finally x is again free. And I got the domain now. To write the interval, better always try to understand with the real line, which is from minus infinity to plus infinity, minus 1. 0 is here, minus 1 somewhere here, and minus 1 by 3 will be somewhere here. Greater than minus 1 by 3, that means this side, according to this. Less than minus 1, less is always left side, remember. Then how we will write? It cannot be in between minus 1 to minus 1 by 3. Now how I will write the domain? It can be here, value of x can be here, and we can write like this: domain is equal to this first part is minus infinity to minus 1. minus infinity to minus 1. Minus 1 close because equal sign is there. Infinity always open. And then we have one more part, so we will write union. Union means together. The second part, minus 1 by 3 to plus infinity. Open, close. So this is the complete solution for the domain of the given function. This is the complete solution for the domain of the given function. Then few questions I am going to solve for finding both domain and range. The next question I am taking is to find domain and range both. And just for concept, remember only this part you will solve for domain. For domain, only this part we have to solve, and for range, the whole function should be solved. Domain is only for this part. For domain, we have to solve only this part inverse. Now I am starting. You see, this is cos inverse. Cos inverse, and for domain, see, for cos inverse this part, we have this whole thing is x, and for cos inverse x belonging to minus 1 to plus 1. That means x lies between, x lies between what? Minus 1 to plus 1. It lies between minus 1 to plus 1, and for x we have 3x minus 1 less than equal. This question already we have done, just explaining once again. And here you have to remove, we have to find out this small x values, which is the domain, and for that we have to make x free. So first we have to remove this minus 1, adding plus 1, minus 1 plus 1, 3x minus 1 plus 1, 1 plus 1. So this is getting cancelled. You are getting 0, 3x, 2. Then remove this 3. So divide by 3 each term. 0 by 3, 3x by 3, 2 by 3. Finally x is, we got the x values from 0 to 2 by 3, and which is the domain of the function. So I can write like this: domain is equal to 0 to 2 by 3. Equal sign is there, so I have to write close interval. So this is the domain, finished. Now to find the range, I have to see whole function. The value of the range means the value of fx. The whole fx, I have to find the values of the whole fx, possible values of whole fx. At first, we'll start with this part. Clearly, I'm finding range. Clearly, this part, cos inverse 3x minus 1, lies where? This one is lying in the range. Range is now cos inverse range is 0 to pi. So this belongs to 0 to pi. This implies I can write like this. The same statement I am writing in this form. It lies between 0 to pi. And from this I have to extend, and anyhow I have to make the whole function here. And to make the whole function, first I need 1 by 2. The whole function I have to make here. First I need 1 by 2, so each term I will divide by 1 by 2. 0 multiply by 1 by, sorry, not divide, multiply by 1 by 2. This second term also multiplied by 1 by 2. And then the third term also multiply by 1 by 2. So I am getting like this: 0, 1 by 2 into, this is remaining same, pi by 2. Then I have to make minus 3. This minus 3, the whole function anyhow I have to make here. So I need minus 3. For that I will subtract 3 from each term. 0 minus 3, second term also minus 3, and third term also minus 3. And finally what I have got? I have got the function fx. This is the function fx, which lies between minus 3 to this number. That is the range. Range is fx. Remember, range is fx. So I can write range is equal to, starting from minus 3, ending at pi by 2 minus 3. Equal sign, so close interval. Here also equal sign, close interval. So this is how we find the range of the given function. I'll solve some more questions. I'm solving. Next question, it is again sine inverse. So two parts. First part is to find domain, second part is to find range. For domain we have to see this part clearly. For any sine inverse of x, x must be where? Belonging to sine inverse ka domain. We are finding domain. This is the domain, -1 to +1. This can be written as x in between -1 to +1, and in place of x what do we have? This is the function 2x plus 1 less than equal to 1, and then I have to remove -1 by subtracting. This one I have to remove at first, less than equal to 1 minus 1. So this is getting -2 less than equal to 2x. This is getting cancelled, less than equal to 0. Then I have to remove this 2 again, for which I have to divide by 2 each term. So -2 by 2, 2x by 2, 0 by 2. So -1 x less than equal to 0, which is the domain. We got the domain. We can write like this. Domain of the function is -1 to 0, close, equal sign, close interval. Now finding the range. Finding the range, this sine inverse, sine inverse of anything, range is -pi by 2 to +pi by 2. So I'll write sine inverse of anything belonging where? -pi by 2 to +pi by 2. This is the range of sine inverse. Sine inverse of anything, range is this principal value range. Now, this one I can change like this. Between -pi by 2 to +pi by 2. So I can write like this. 2x plus 1. It is lying between where? -pi by 2 to +pi by 2. And then I have to make the whole function I have to make here. For which first I need this 3 by 2. So multiply each term by 3 by 2. I need this 3 by 2. Multiply each term by 3 by 2. So -pi by 2 multiplying by 3 by 2. This second term also multiply by 3 by 2, and the third term also multiply by 3 by 2, and finally I am getting multiply by 3 by 2. So I am getting -3 pi by 4 less than equal to, this is remaining as it is, and what it is, 3 pi by 4. Then we have to bring another 5 here, +5. So for which we have to add 5 in each term. We need another 5. So I'll add 5. -3 pi by 4 plus 5 less than equal to this term also +5, and third term also adding 5. And you see finally we made the function fx. That was our aim, to make the function. So what we are getting, 3 pi by 4 plus 5 less than equal to fx less than equal to, keeping as it is, and fx is what? Fx value is set of values, possible values of fx is the range. Set of all possible values of fx is the range. So we got the range here. So I can write like this, range is equal to what? This number -3 pi by 4 plus 5 to 3 pi by 4 plus 5, close interval, because equal sign is there, and this is the range of the given function. So this is how we find the domain and range. So this is the end of this lecture, and if you, whatever explanation given, you first memorize this table and explanation given, go thoroughly, and any question given to find the domain and range you can easily solve. This is the fourth video. All the remaining video in order given in playlist. You watch, you find out the playlist in which all the videos are given in systematic order, so you can watch serially.